Let's look at another example. The limit as x goes to 0, sine squared x over x. Again, we're going to separate because we can't evaluate functionally. We need to have another technique. So let's look at this as sine x times sine x over x. And this is equal to the limit as x goes to 0 of sine x over x times the limit as x goes to 0 of sine x over 1. And this is equal to, now again, this product is only justified if both of these limits exist, which they do. This is our limit of 1. This one we evaluate functionally. The sine of 0 is 0. So 1 times 0 is 0. Now this would be one method. There are many methods oftentimes. So let's look at another method for doing the same problem. All right. So let's rewrite. And we know sine squared is equal to 1 minus cosine squared. So I can replace sine squared with something that it's equivalent to, namely 1 minus cosine squared x. Now 1 minus cosine squared x is the difference of squares. So we can write the limit as the difference of squares. 1 minus cosine x times 1 plus cosine x over x. Again, we can separate. And with this separation is only valid when when both limits exist. All right, now this limit, the first limit, is equal to 0 from here. The second limit can be achieved by functional evaluation. This is just 1 plus the cosine of 0, and the cosine of 0 is 1, so this is 0 times 2, which is 0, which is the same answer that we obtained in the first case. Two different ways to do the same problem. And we should underscore, in terms of good form, we always have to write the limit at each step. If you don't write the limit at each step, it's not going to be written correctly. Now we don't write the limit at this step. Why? Because I'm evaluating the limit. It's at this step where the evaluation took place. Namely, the limit as x goes to 0 of sine x over x is 1 by this theorem. And the limit as x goes to 0 of sine x is equal to the sine of 0. So there's no limit here because we've evaluated both of these limits in terms of the product. The same holds for this computation. You have to write the limit at each stage of the problem. If you don't, it won't be written correctly. Again, it's not written here because this is the step at which we evaluated both of the limits comprising this product. Okay? Very good.